So here I have the example. So talk about scenario first. Mortgage process time. So we say a faster loan processing time produces higher productivity and greater customer satisfaction. So a financial service institute want to establish a baseline for their process. So you talk about what is our average mean processing time. And they want to determine if their average time, which is mean processing time, is different from their competitors. Competitors say, our average is 6 hours. So I want to compare ours versus 6 hours, which is competitor's claim. Then, so the analysis randomly select 7 applications, right? Because this is a big company, they have tens of thousands of loans. So they just randomly select 7, and they can calculate what's going on. So I have the data here, just like a loan number and also the hours. So for those 7 applications, they can manually calculate how long it takes to process the loan. So we have the number something like 3.25, 4.5, 3.7, and something. So some small numbers, also some big numbers. Okay, so here's the scenario. The question is, I want to compare our average versus 6 hours. Okay. So before we talk about how to do this, how to analyze this in Minitab, we're going to talk about what is statistics, right? We're going to use statistics, yes, but what is statistics? When you talk about statistics, always you have a population you want to study. So in our case, tens of thousands of loans. These are my population. So I'm interested in the population. When you have a population, then you have some parameters in the population. We talk about mu, which is average of those tens of thousands of loans. That's the average mean. And also you may have standard deviation, like spread, right? Sometimes you get 1 hour, sometimes you get 10 hours. So what's the spread for this population data? We use mean and standard deviation, or mu sigma. However, mean and standard deviation, these are for continuous observation. Continuous means you record number 2.5 hours, 3.9 hours. It's a continuous observation. What about proportional data? Which means sometimes you measure yes-no answers, pass, fail. In this case, we talk about proportion. So what's the proportion of failure? So that's, we use proportion data. So that depends on the data type. You may have mean standard deviation, or you may have proportion. So these are the 3 parameters I'm going to interest in, called population parameters. Okay, for some reason, it's impossible, or it's too expensive to get everything, right? You're going to measure tens of thousands of loans, or you have to measure everything. It's just impossible, too expensive, takes too long. Then we're going to apply, we call a sample. We're going to take a sample, a random sample. So here we take sample 7 sample size. So from those sample, I can know the sample size here, 7 samples. And from those 7 samples, I can easily measure the average, right? I use X bar to represent. And if you talk about standard deviation, easy to calculate. Proportion, easy. So from the sample, it's very simple to get the average, sample mean, sample standard deviation. However, I'm not interested in these sample numbers. I'm interested in the population parameters. So what's going on with the population, mu, sigma? So we're going to use the information in the sample to make an inference about the population parameters, which means use these numbers to guess what's going on with these population parameters. So it's like a game. We use this number to guess what's going on. So the whole approach, we use a sample to figure out what's going on with the population parameters. We call a statistical approach or hypothesis test, right? So we understand what is statistics. You use a sample to figure out what's going on with the population. And the whole approach, hypothesis test. So here I list general steps. These are the general steps for any hypothesis test. You're going to say the question. You tell what's going on. What do you want to compare? Here, I want to compare my long average versus 6 hours. That's my question. Then you collect sample data. So in our scenario, 7 samples were collected, and then we prove it. So we calculate, we figure out what's going on. So these are just general steps. So I put them into 4 detailed steps for any hypothesis test. Step 1. You need to state the question, but when you state the question, you have 2 statements. First, called non-hypothesis. H-no. Some people say H-O, H-no, the same. So my understanding of non-hypothesis is just like nothing is going on, everything's okay. We follow the 6-hour curve, our average is 6. Right? It's like a non-hypothesis test, non-hypothesis statement. And you have another called alternative. Some people say H1, HA, right? Alternative. The alternative hypothesis always contradicts to your HO. Because HO is that everything okay, we follow 6-hour curve, average is 6. But alternative, or H1, HA, could be we are greater than 6, less than 6, or not equal to 6. So I'm going to talk about more on H1 later, so in a few slides. Okay, then step 2. You summarize all the sample information into a single number. What does it mean? Let's go back. So because when you have a sample, you have these kind of numbers like information, sample size, and sample mean, and sample standard deviation. So you have this information in front of you. So I just put those 3 numbers into a formula, get one single number. That's called summarize all the sample information into a single number, which means use one number to represent the whole sample. Okay, that's step 2. Step 3. We're going to calculate how likely to see the number in step 2, assuming H0 is correct. All right, I'll highlight this called assuming H0 is correct. So you know what H0 is. H0 means everything's okay. We follow the 6-hour curve. Our average is 6. So we just say how to interpret this. So suppose we pick up 7 samples. Average is 7.5. All right. So suppose we have 7 samples. Average 7.5. So how to interpret step 3? We say assume our population gonna follow the 6-hour curve. Average is 6. Then how likely to see 7 samples with average of 7.5? All right, it's a little bit tricky. So assuming population average is 6, how likely to see 7 samples with average of 7.5? How likely? What does it mean? It is a probability. So give you the probability. That's a p-value. All right. So people always confuse, what is a p-value? It is the probability to get this sample, assume you still follow the original H0 curve. So that's a p-value. Okay, think about this. Does the low probability support H0 or H1? Ask yourself this question. H0 means, yes, average is 6, right? And H1 means our average is different. So we have a different process. Average not 6, that's H1. So if our probability is low, should I support H0 or H1? All right. Now let's figure out the answer. Okay, I have these 2 curves. One is a green curve, another is a black curve. Green curve just like our H0. So average is 6, follow a nice normal distribution, and we figure out the sample mean is 7.5. So we calculate how likely to see a few samples with average of 7.5. That's the area under the curve, which I pointed here. Okay, this small area in terms of percentage of total, that's a probability. How likely you get a few samples with average of 7.5. So if P is low, it means the low probability. If this part is low, like this case, like this graph I illustrated here, I probably say, we probably have a sample from the black distribution. Unlikely we have a sample from the green curve distribution. It's more likely we draw a sample from here rather than from the green curve, which means we're going to support a different distribution, or H1. Right? That's why people say P is low, H0 must go. We go for H1. So this is the reason why. But what about P is high? So here's the H0 curve, and we draw some samples, averages here. It's pretty close to the mean, and the area under the curve, the P is high. I'll probably say, yeah, there's no doubt we still follow the same curve. If it's the same curve, we go for H0. We still follow the same curve. So if it's hard to remember, just say P is low, H0 must go. Okay, so we go back to the mortgage example. My H0 going to be mu equal to 6. And what if you pick up some samples, average is 5.8? What do you think? Should I support H0 or should I support H1? What if the sample mean is 2.5? You say we have a different curve or we still follow a 6-hour curve? When I ask this question to 100 people, they may give me different answers. Different people are going to give me different answers. Some probably say the first 5.8, yeah, pretty close. Maybe we follow 6-hour curve. But if it's 2.5, some people may say, yeah, we still follow 6-hour curve. Some people may say, no, we're different. So which means I don't want you to give me the answer. I'm not going to ask you. I'm going to ask Minitab. The decision is going to be based on your p-value. Right? When you make a decision, we look at the p-value. I'm not looking at the sample mean. If you're going to make a decision based on a sample mean, we call this mistake called typical zero statistic mistake. You're not going through the whole process. You just pick up based on the sample mean. So decision you're going to make based on your p-value, either reject H0 or fail to reject H0, which means you support H0. Reject H0, you support H1. We say we have a different curve. When you reject H0, we say we follow a different curve. We say the result can be statistically significant. Statistically means we'll based on the data, we'll make a decision. And I'm going to introduce another concept. It's called practically significant. All right. So how to see the difference? Suppose we talk about 5 minutes delay. Okay. If we do business like overnight delivery, so we ship some parcel from Sydney to Perth, which is 3,000 kilometers away, maybe 12 hours or 24 hours. But we are 5 minutes late. Will your customer complain? Most people probably say unlikely, right? It's a 24-hour delay, 5 minutes late. But if we talk about city train services, and the trains are 5 minutes late, everyone will complain. All right? So, which means 5 minutes, which is the same number, for overnight delivery service, practically not significant. But for the train services, 5 minutes, practically significant. People will complain. So my conclusion is when you try to make a decision what to do next, not just look at a statistical result, not just a p-value. You also need to combine with your process knowledge, because the practice is significant or not based on your process knowledge. combine together and make a decision, decide what to do next. Okay, that's what I want to say. Now we come to the first test. We talk about the t-test. When we're going to use one sample t-test, we use one sample t-test when you have continuous data. So one column of random samples of continuous data, like our case, 7.5, 2.9 hours, that's called continuous data. Why are we going to use the sample t-test, one sample t-test? We're going to use this test to see whether the mean something like the average transaction time is on target or off target. Excuse me. Does customer service meet expectations, right? So mainly we compare the average versus something, versus a target. That's how we use one sample t-test. All right, so we talk about 4 steps, right? So so we're going to say, again, we have 4 steps for one sample t-test. So we have one sample continuous data, and also we have a target. Target is 6 hours. So step 1, we're going to have 2 statements, H0, H1. H0, everything's okay. We follow 6-hour curve, mu equal to 6. For H1, we have 3 possible ways to write H1. Could be mu greater than 6, less than 6, or not equal 6. Then the question going to be which one to choose. You can only choose one. You can't choose 3 of them. So you can only choose one. How to choose? Based on your research interest. Research interest means, suppose I'm a manager and we are losing business. People complain you're too slow. All right, so this is some question in my mind. So I want to run the hypothesis test. I'll pick up some samples. What I try to prove is, if the mu greater than 6, we got a problem. So we talk about we are too long, we are too slow. So mu greater than 6 to be too slow, then that's a problem. We got a problem. But in our case, we talk about is our process on target or what is our averages compared to 6? Then we say mu not equal to 6. So we compare on target or not on target. But if you talk about we are too slow, we're going to check what is going on. Your H1 going to be mu greater than 6. Which means if average greater than 6, we got a problem. If it's average equal to 6 or less than 6, we are totally fine. All right? So it depends on your research interest. Because when you set up H1, you're going to put different risks, right? Either on one side or two different sides, two-sided. So that's the risk you're gonna put it on. Okay, so we fix H0 and H1. Step 2 gonna be summarized number. So we call summarized number, put those numbers into a formula and get one single number. The formula is a bit interesting, but in my training, I'll probably only write 2, 3, maximum 3 formulas. But this is one because it's very important. It's going to introduce a basic concept. That's why I always talk about this formula. The summarized number we call T equal to the X bar minus mu, which is a sample average minus the target. That's the top, right? At the bottom, we have something like S, which is a standard deviation from the sample, and also the sample size, which is the square root. So I try to explain these two parts. At the top, where we are, which is X bar, and where we're supposed to be, we call distance or difference between where we are, where we're supposed to be. The bottom part, that's S, which is standard deviation or variation, and consider sample size. So the bottom part is variation, stands for variation. So actually the summarized number is equal to the distance over variation. So the ratio between distance and the variation. So what does it mean? So look at these two curves. I have two curves here, right? I try to compare which is high, which is low. You'll probably say they are too close to each other. They overlap a lot, and I can't tell which is high, which is lower. Why? Because if you look at distance over variation, what is distance? This part is the distance between the two curves. And talk about variation, this one represents the variation, right, of the curve. So distance over variation, the ratio is not big enough, right? They are pretty close, not big enough. Distance over variation, I can't tell which is high, which is low. But if we put in a different scenario, here these are the two curves I try to compare, and this is a distance, and this is a variation. It's very clear they are different. Why? Because distance over variation, the ratio is much bigger. That's why they are different, right? So this can give you some idea. You understand, if T, which is distance over variation ratio, is big enough, I'm going to say they are different. If the T, which is the ratio of distance over variation, is not big enough, I'll probably say they are the same, right? Okay, next step, we calculate the p-value. If you still remember in uni, you have a T table based on the p-value and also degree of freedom, you get the p-value. So these are going to help you find the p-value. So this relation is between T and the P. You probably want to say, if T is high, it's more likely they are different than the P, which is a p-value, going to be low. We support H1. They are different. All right, this is sort of relationship. So T and P are related, and you don't need to worry about that. You need to have calculated the P straight away. We find the table, get the value. So the step 4 will be the conclusion. Reject H0 if P less than 0.05. So you're going to do this. You look at the p-value, they're different or they're not different. If less than 0.05, we say they are different. So we go for H1. Some customer ask me, okay, can you do this? We're going to ask Minitab to do this. It is not a big question. It's very easy. Just compare P versus 0.05. But we don't know very well. We don't want to do this because what if the p-value is 0.051? If you ask Minitab is a machine, right? We compare 0.051 versus 0.05. Okay, bigger than that, no problem, go for it, right? They are the same. What about this is $1 million decision or big project? You can't just based on just the p-value and judge what to do next. So we say, do not just focus on the p-value. You also need your process knowledge. All right, combine together and make a decision. Do not just focus on the p-value. All right, so we talk about assumptions. So talk about all the tests, they have assumptions. The assumptions for one sample t-test. First assumption, we'll call this normality. Data are sampled from a normally distributed population. I should say roughly. Okay, roughly normally distributed. Why we have this